So we have this question on Leetcode Two Sum. Given an array of integers num and an integer target, return indices of two numbers such that they add up to a target. And you may assume that each input would have exactly one solution. So let me just go through this screen. So we have numbers such as 1, 2, 5, 7, 8, and 9. And in this is given in an array. And we have given a target, which we can say, let's say, um, 9. So from this diagram, you can clearly see that the answer would be um, this 2 and this 7, or the answer could be this 1 and this 8. We have to return the indices, like this indices is 0, 1, 2, 3, 4, 5. So we have to return the indices. We can return the first indices, like this is 1, then we can return 0, and the second index, that is 8, and the index would be 4. So this would be our answer. Now what we're gonna do is, by brute force method, we can do this. We will just iterate this array, and again we will be using another for loop to check whether each of the elements is s- after summation gives this target or not. So that we can do. So now let me jump to the code. First I will write a for loop which iterates the array, and then I will do another for loop so the first element of this second for loop will be from 1. Here initially, if I take the first element, then I have to check the next element from the second element onwards. So if I select the first element, this one, then I don't need to check this first element again. I will be going from the second element only. So that's the reason I'm checking this from the next element. So I'm going to write equals to 1 and nums less than equals and also remember that you are not able to iterate through this size. You have to iterate through the second last one, because here it's starting from 1 and here you are going to the end. And now I'm going to check whether if the nums I and nums of j equals to target or not. If it's target, then I'm going to return the two indices I and j. And to complete this main function, I have to write this. You can write any arbitrary number like this, -1 and -1. Yeah, the code will not be reaching here because it's given that you may assume that input would have exactly one solution. So I have one solution. I don't need to check whether this one is correct or not. So yeah, let's run this code. And some bits, yeah, it's subsected. Okay, so this was the brute force approach. So that here I'm running for big O of n. Here also the complexity is um, big O of n, and yeah, here. So the complexity is total order of log n, not log n, order of n square. So the complexity is basically order of n square, which is not a good complexity. So we can do is we can make the code more optimized. So in this diagram, you can see here, what I'm going to do is, instead of going through this one, this all these arrays, what we can do is we will store these differences in a hash map. So instead of iterating, what we are going to do is create a hash map h. In this hash map, I'm going to map these numbers with the indexes. So 1 will be mapped to 0, 2 will be mapped to 1, 5 will be mapped to 2, 7 will be mapped to 3. So this will be our hash data. And um, in this hash data, we will first iterate through this element, through this array, and then we will check whether um, this element, and we will calculate the diff first. The diff will be target minus the ith num. Okay, so the difference of this number will be 8. Let's store this in an array again. So the difference of 1 minus 9 will be 8, 2 minus 9 will be 7, 5 minus 9 will be 4, 7 minus 9 will be 2, and 8 minus 9 will be 1, and 9 minus 9 will be 0. So you can see these are the differences. Now you can observe one thing. If I iterate to the first element, and if I check in the hash map whether this difference, which is 8, is present in the hash map or not. So we can easily find in the hash map whether the element is present or not. See, in the hash map immediately the difference 8 is present. If this difference is present, that means there are two indices, there are two in numbers 1 and 8, which gives us number 9, and hence we will return the indices of the um, element. Let's Okay, so first let's create a map h. In this map we will initialize all the numbers. I'm going to write this h of nums equals to I. So the elements are mapped to their indices. Now the initialization is done. Now I'm going to run a for loop from I equal to 0 to the last element. And inside this for loop, what I'm going to find is the difference. Let's take this variable diff, which is equals to target minus nums I. Now all I have to do is check whether this difference is present in the hash map or not. That I can do this by doing this. I have to check whether um, the difference is present or not, and return the difference, like the array indexes. So the array index will be I and the index which is mapped to difference. Now this is our code, but one more thing you have to remember is that this index of difference should not be equals to I, which means in this diagram, if there is one element such as, let's suppose here I'm making a new number 1 2 1 1. So now I give the target as 1. So I give the target as 1. Okay, so this is the indexes. Now if I iterate to the first element here, this one, this number is already, if and the difference is also like 1 minus 1 equal to 0. So the difference is also there. Now again, I make an array for the differences, which is 0 1 0 1. So I there is one difference, and the difference, so the fact is that you cannot have the indices similar to the index which you are currently checking for. So let's see this code. Okay, something is wrong here. For int I equal to 0, I less than nonce I plus. What is wrong here? Int I, okay, I haven't written the I equals to 0. H nums. Oh my, okay, I haven't mentioned the index. Okay, I forgot to mention the index over here. Yeah, so now you can see the its code is working. And one more thing, I have to use unordered map in order to reduce the time complexity. So to store this elements in this unordered map, we are having a time complexity of big O of n, and to store this one, we are having time complexity of big O of n. So now you can see the total time complexity is 2n, which is again which is big O of n. So now you can see that um, instead of n squared time complexity, we are having big O of n complexity. The only difference is the space complexity increases, which is of order of n. In the previous example, the complexity, there was no space complexity, it was 1, but this is a much more efficient algorithm. Thank you.